Hello, everyone.
Hello.
Hello.
Well, because we're an interactive audience, this will be a lot of fun. All right, let's get started. Thank you very much for having me. I'm very excited to be here. Today will be full of very interesting conversations, and they're going to center around a tool with which we're all quite intimately familiar with.
No problem.
That tool is, of course, JavaScript. It's evolved from its roots as a scripting language for the web into something much bigger, a language for general-purpose computing. And of course, we're here at a conference run by the node.js community in Japan. And node.js is a server-side programming environment, or it has been used for server-side. It's also been used for CLIs and other such tools. But we will be hearing lots of interesting talks about other applications, such as TensorFlow will be introduced to you by Eileen. We will also hear about applications from Peter and Akifumi and others about what you can do on the server side, different tools, different techniques. And those will all be very interesting to hear. We'll even hear about how you will show the beauty of mathematics using JavaScript. Those are very exciting applications for a programming language. For many of us, a programming language is more than a tool. How do we describe it? It's not just a hammer. But we can borrow from a certain computer scientist named Kenneth Iverson, Canadian computer scientist, and his paper called Notation as a Tool of Thought. To consider programming languages as both notations and as tools for thinking is very interesting. They are ways for us to think about problems, to frame ideas. Programming languages, for better or for worse, shape how you approach problems. They shape how you think. The design and implementation of something so powerful as a tool for thinking might be best left to experts, you might say. A mathematician, perhaps, someone who specializes in logic, someone with a degree, someone who works on compilers. But in fact, it is diversity which makes us much stronger, because a tool without the user does not work. A tool without application does not work. Having a JavaScript developer's perspective on language design is really powerful, because then we can better design the tool to meet you halfway and to help you build your mental models for your applications. That is the purpose of my talk today, which is to invite you to be a part of this process. All right, so you might look at me and say, you know, this sounds great, but one does not simply write a compiler or design a programming language. Here we have one of the classic textbooks on how you write compilers and on how you design programming languages. And it's clearly telling you directly from the cover that you need at least a sword and a shield, maybe some armor, and there's going to be a dragon involved. But if we take what I've used as my theme for this talk, Lord of the Rings, and we consider the meme in its broader context of the story, then we realize that, as they say, one does not simply walk into Mordor, except for this individual, who quite literally walked into Mordor. And that is what we will be doing today. We will be walking in to writing a compiler, and we will be walking in to doing some language design of our own. How do I know you can do this? Well, it's because it's what I did. And not just me, many of our best contributors are self-taught. So without further ado, allow me to introduce myself. My name is Yulia Startsev. I work on the SpiderMonkey compiler. SpiderMonkey is the JavaScript and WebAssembly engine inside of Firefox. You might be interested that I did not train as an engineer. I trained as a painter. And just to make the long story short, I somehow became very interested in computers, in programming languages, and in compilers, and that's how I ended up here today in front of you. I would also like to introduce you to TC39. TC39 is the standardization committee which handles the design and stewarding of the JavaScript language, as well as a couple of other standards which you'll also hear about today. I'm sorry, I've forgotten the name. I had it in my notes, but I'm not looking at them at the moment. But we'll also hear about Intel, which is another one of the standards that this committee handles. TC39 is a part of a standards publishing body called ECMA International. It used to stand for European Computer Manufacturers Association European Computer Manufacturers Association, which means that ECMA's script stands for something similar. But this is no longer the case, it's now simply ECMA. By the way, you'll notice that the website is fully localized in Japanese. This has been done by volunteers, and it's a great place if you aren't sure how to get started with working on something standards adjacent. The website's a great place to contribute because we always need translations of new proposals. Next, I would like to very briefly introduce you to the TC39 process, which is the way in which a feature is added to the JavaScript language. This is going to be our primary focus of this talk. The process is made up of 5 stages, but because we count from 0, it looks like we have 4 stages. The final stage is stage number 4, and with this is all the intro you're going to get, and we're just going to go straight into designing our first feature and implementing it in SpiderMonkey. So, off we go. Here we are, at the beginning of all things, in stage 0, the very start of the process, of the TC39 process. What is stage 0? Well, stage 0 is basically an unpresented idea. Usually this takes the form of a GitHub repository, and there aren't any formal requirements. Usually you create it from the TC39 template for proposals on GitHub. And the main thing we're looking for when we're creating our first JavaScript feature is we're looking for a problem that we want to solve, a problem statement. We are going to take a problem statement that was introduced to the TC39 committee around 2020, if I remember correctly. And it was first introduced to the committee with the following problem. Here, I don't know if this is big enough for folks in the back, I'm just going to read it out. We have an array with the elements 1, 2, and 3. And we are doing a filter on it. Array filter, I is greater than or equal to 2. Now, with a show of hands, will this call result in a 1? Or will it, so how many people think this is going to be a 1? Or maybe I don't have an interactive audience. Very well, maybe we don't have an interactive audience. But there are 2 potential outcomes from this call, either 1 or 2, 3. And the proposal author, Justin Ridgewell, was looking at this and thinking, gosh, I'm always going to MDN and trying to figure out what this call is going to do. So he proposed to TC39 that we investigate this API and see if we can change it somehow. Now, you might think, oh, but array filter is obvious. But the obvious is not obvious to everyone. Let's consider a common problem within the design space, which is how doors are designed. Often you will see that a door has a sign on it saying push or pull, because it's not self-evident from how the door is designed, how to use the door. However, you can design a door so that it is self-evident how to use it. And here's an example. I'm not sure if these are common doors in Japan, but this door functions with a button that you push, so it becomes obvious that you have to push the door in order to open it. The same kind of design thinking can be applied to APIs and to language features. So filter is designed with this kind of a use case in mind, where your goal is the coffee cup, the contents of the coffee cup. So you are filtering in. However, you might be conceptualizing your problem in a different way, which is you may want to be filtering something out. Here we have panning for gold, so you are trying to pull out gold from water. Now, this is an example of a case where a programming language model may help or hinder your mental model of your problem. The filter API may hinder certain versions of writing this kind of code when you're trying to describe your problem in programming languages. So this is the problem statement, and this is what gets accepted into stage 1 by the TC39 committee. We're going to further investigate how can we make filtering more clear, how can we help programmers model filtering in other ways. So that's our problem statement. Hooray, we've achieved stage 1. So, but what does that actually mean? What is stage 1? Well, in stage 1, we explore the proposal in further detail. We want to do a lot of research looking at how programmers are writing JavaScript today, what kind of problems they're encountering, have we actually modeled the problem correctly, are we solving a real-world use case? Now, the proposal champion, Justin, went and did something called a corpus analysis. A corpus analysis is when you look at a body of literature or, for example, a number of code bases and try to see how common a certain practice is. And what he was looking at, and I'm very sorry because I realize that this text is very small, he realized that he collected a number of methods from the underscore library and realized that he could better understand what the landscape was by the number of usages from the library in users' code. For example, he originally conceptualized that what we were going to add to the array prototype were two methods, select and reject. If you've written Ruby, you're probably familiar with select and reject. But from looking at the underscore library, he discovered that select actually only had a tiny percentage of the usage of filter. So it didn't make sense to introduce an API like select because it was not actually being used by JavaScript developers. Then he took a look at the next potential API, which was reject. And reject made up about 12% of the calls from this underscore library. This is more convincing, so he felt justified to continue the investigation and see if he could introduce a new method, such as a filter reject. And that is precisely what he did. He drafted a proposal which was a companion method to filter, which is called filter reject, which would give you the opposite outcome from filter. However, you probably noticed there was a third line to this table, which is very difficult to see from the back. I'm terribly sorry about that. But this final line says partition. What is partition? Partition is not used so often. It's maybe about 1% of use cases, but it does something different than filter does. What partition does is it returns two arrays. You take an array and you break it up into two groups. This is functionally different, but it potentially also solves the same problem, which is confusion about how array filter works. So, Justin took a look at these two other options and considered them in more depth. We could do array partition, which splits into two arrays, but this is a more specific version of a more general problem, which is array grouping, where you can group the array into arbitrary number of groups. He considered this and decided we are not going to do array partition, because array partitioning can be implemented by array grouping, and we can't add too much to the array prototype safely, because we will run into web compatibility issues, which we'll talk about in a minute. So, he removed this from the list of proposals that he presented to TC39. Finally, he went to committee and presented the two methods, filter reject and group by. The committee rejected filter reject. The reason that they rejected filter reject is because it was simply an alias on filter, and it did not necessarily correct the mental model of programmers to consider these two different ways of writing JavaScript. However, because group by was genuinely adding new functionality to the language which wasn't there before, group by was accepted, and we moved forward into stage 2 with group by. A little bit more detail here. I'm simplifying a little bit. The proposal is larger in scope. There is a second method called group by to map, which we will not cover. Please take a look at the proposal for more details. All right, so we are in stage 2. What does this mean? In stage 2, we start to write the specification text. You might think that because the specification is over, I think now 1,300 pages long, you need to read the entire specification in order to be able to contribute to it. But this isn't the case. You can contribute without reading the full specification text and still do a relatively good job because you can understand it from a slice of the specification rather than fully. Eventually you might read the whole thing, but it's not a requirement for contribution. We will go through the specification text together, but we will do it as part of the implementation. In stage 2, usually you have more exploration, but in the case of this API, it moved very quickly from stage 1 to stage 2 to stage 3 because the design decisions were clear. In the case of stage 2, we had one naming change that occurred at stage 2. So, it's finally time for stage 3. Hooray! What does that mean though? Well, stage 3 is where we start to implement. This is the most expensive stage because this is where engineering work needs to happen. It's also when we potentially ship to developers a testing version in test browsers such as Nightly, Chrome Canary, VS Code, the Safari Preview, and so on. So, we will be implementing this together, and in fact very quickly together, because we don't have so much time, inside of SpiderMonkey. This is the Firefox JavaScript engine, as I mentioned earlier. I won't be covering how to write a compiler in this talk because it's out of scope. However, if you're interested in that topic, there will be a talk later today by, and excuse me if I mispronounce this name, Anirudh Sharma, who will be talking about V8. If you are interested in writing a compiler from scratch, then there is this very interesting paper and workshop an incremental approach to compiler construction, which you can read and try to implement your own compiler in a very natural way. The part of the code base that we are going to be touching is something called self-hosted code, or self-hosting. Self-hosting is when the tool used to write the feature is the same as the tool that will be executed. So in this case, so Rust, for example, is a self-hosted compiler which is written in Rust. So in order to evolve the Rust compiler, you write the new feature in Rust. We are doing the same thing. In order to evolve the JavaScript language, we're going to write our JavaScript feature in JavaScript. Within the context of V8, they have a similar technique, but it's called turbofan, and it's not written in JavaScript, but they use it for the same purpose that SpiderMonkey uses self-hosting, which is to write library methods. All right, well, without further ado, let's write some code. Oh. 1 second, I need to figure out where my mouse is. There it is. Okay. So, here is my, I wish I had a different mic. This is going to be harder than I thought. I didn't consider, I practiced this and I didn't consider how hard it was going to be to not have both hands. Okay, here we have the SpiderMonkey codebase. We are inside of the JS source directory, inside of another directory called built-in the array C++ file. Oh my god, are we going to write C++? Yes, we are about to write some C++. It's extremely, extremely scary. And that's how much C++ we're going to write. Okay, so what was that? This is a macro, and it takes a couple of strings, and you don't have to understand anything about what this is doing except copy-paste whatever line you see here and just add your self-hosted built-in method like this. So that's all we need to do for the C++ to work. Before we get started, I'm just going to demonstrate that our compiler actually isn't implementing the feature. 1 second. So we are running the JavaScript engine. It's at the bottom there. And here you see we have a type error. Okay, let's move on. So we have added our self-hosted code. Fantastic, everything's working. This is beautiful. And now we're going to move inside of a different file within the same folder. It's called built-in array.js. So this is where you are going to find all of our built-in methods, like the library methods for the array function. So array every, array filter, array, etc. is all here. Array reduce is also here. And I've prepared the function for us. And let's get started. So, this is hard to see, isn't it? Okay, so here we have I've put everything in line bilingually, and we're just going to go through it stepwise. Step 1 says, let O be question mark to object this value. So this is looking really confusing. Like, what does that actually mean? Sorry, we need this. Okay, so here we have the specification. Within the specification, we have several sections. So this is the proposal text. This isn't the full specification. We have, it's kind of like a slice of the specification. So at the top here, you'll notice something called a note. Notes are something called non-normative text. Non-normative means it does not impact the implementation. It does not impact what we write as code. However, it explains to both JavaScript developers and to implementation authors how certain parts are intended to work. So for example, we have here a callback function variable, and if you don't know what it is or how it's structured, it might be difficult to understand it just by reading specification text. So we have explanation here about how it works. In the case of callback function, it describes that this is a function that accepts 3 arguments. So that's the function of a note. Now down here, you're going to find something that looks a lot like code. Also, it looks a lot like the code comments that we had there. When the group by method is called with 1 or 2 arguments, the following steps are taken. So this is normative text, this is what we're implementing. This first line is what we saw in the code base. Let O be question mark to object this value. What is all of this going on here? So you might think that this value, is that perhaps the this value that I find in my function within JavaScript? And if that's what you're guessing, then you would be correct. The this value here will be the this when you call a method on an array. So it will be that array. Next, we have the toObject call. What might this be, and how might you discover that information? The way that you would do that is by going to the full ECMAScript specification. And to find it, we have a search. Well, and I can't spell because I'm doing it with one hand. And here we have the definition of toObject. I will go through this pretty quickly because we're a little low on time. So toObject. You'll notice that the description here is different than the description of the previous function we looked at. So we were looking at the prototype method groupBy, and now we're looking at something called toObject, and it opens with the abstract operation toObject. An abstract operation within the JavaScript specification is an internal function that is not exposed to JavaScript developers. This is something that you can only use within the specification. You'll also notice a very interesting feature of abstract operations, which is that they are typed, unlike JavaScript methods. So whenever you see parentheses like this inside an abstract operation, that is the type associated to this argument. The next thing I will point is that the toObject, basically the steps that it takes is a match on this table. And for brevity, I will point out that what toObject will return is it will return the object as, because we're passing to it an object, it will return an object. An array type is an object type. One other thing I would like to point out to you is there's some interesting language here regarding a normal completion. So let me read the full sentence to you. The abstract operation toObject takes argument, an ECMAScript value, and returns either a normal completion containing an object or a throw completion. So what is a normal completion? This is, again, something that is specification specific. So you're familiar with JavaScript types, objects, you're familiar with numbers, etc. However, a completion record is inside of the specification to help us talk about things within the specification. You can think of it as a wrapper, which has a type that can be normal, break, continue, return, or throw, and it has a value slot. So those are the two most important parts of a completion record. Another thing I would like to point out is we have a couple of shorthands. The two that are important for us right now and for much of the spec is, the first one is normal completion. Another thing to point out, normal completion is about how when we change points in the code, like for example you have a function and you have a return call, then you have a normal completion that takes the value from the end of that function and transports it to the variable assignment inside of your inside of the place where you call the function. So that's a normal completion and it carries that value. We also have a second type of two completions that we're interested in. A throw completion is when you throw an error. And the final kind of completion is that we will talk about today is an abrupt completion, where an abrupt completion is anything but a normal completion. We are probably not going to write very much code today because I've only got 7 minutes left. So that's just how it is. Okay. So the last question we have about the specification is, what is this question mark? Like, and how do you find that? Because you can't really search the specification for a question mark. This is something that it helps to have a guide for, because it is difficult to find. So I will show you how to get to it. There is an important chapter within the JavaScript specification, and that is chapter 5, Notational Conventions. Notational conventions will tell you how to read the specification. This includes how to read the grammar. However, we are not doing a syntax-based proposal, but we are looking at how the algorithm is working. So we are going to skip over syntactic and lexical grammars, this part of the chapter, and we're going to go to 5.2, algorithmic conventions. Algorithmic conventions explains how algorithms are laid out within the ECMAScript specification. And again, because there's a lot of information here. We can't cover it all in 30 minutes. We are going to go to, because I know where to look, return if abrupt shorthands. And this is the segment of the chapter that explains to you how the question marks work. This is a shorthand so that you don't have to write everything out. And the shorthand is for this step, return if abrupt, and then it takes as its argument the operation name. So you'll probably recognize that this looks an awful lot like the step we were looking at in the specification. But what does return if abrupt do? Return if abrupt is the same thing as asserting that the argument that return if abrupt is taking is a completion record. We just described what a completion record is. If the argument is an abrupt completion, and abrupt completion is anything that is not a normal completion, then we will return the completion with argument. So this question mark doesn't work like a function, actually. This works more like a macro, because this gets expanded inside of the spec text, and when we return from here, we return from the entire algorithm. So we return from group by with, like if we hit this abrupt completion point, we return from group by with, for example, an error. Else, set argument to argument value. What we are doing in this final step, in step 3, is we are unwrapping the completion and taking the ECMAScript value out of the completion and inserting it into the step. So this O will be the value of the array that this is being called on. We have 5 minutes left. Oh boy, this is going to be fun. I'm going to describe the specification at a high level. We will go through it quickly. I will very quickly implement it in JavaScript, and then we will finish that part of this talk. So let's walk through this quickly. It's like code. Like once you realize that this is like code, it's a lot like writing JavaScript. So we we extract the array, then we say let length be the length of the array like. That's going to be a number. If callable callback function is false, throw a type error exception. So this is basically an if statement that takes an argument and checks if it's not there, then you throw it when you get out of there. Then here, this is a loop. Let k be 0, and while k is less than the length of the array, iterate. And increase the k, set k to k plus 1 at the end of each step. It's just a for loop. So let pk be toString. Okay, so these two steps, they're a little bit confusing if you don't realize that you need to extract the value from everything as you work. This is easier when you do this in JavaScript. We actually skip these steps when we do it in JavaScript, but if you're doing it in C++ and whatnot, this is really important. Then we pull out the property key. It's much easier if I could show you how to program it, but I don't think we have enough time. So basically what we're doing, at a high level, we are saying that we have a bunch of groups, and for each group, we are iterating through the array and seeing if the check is true or false for that group, and adding that value into the appropriate group as we go. So we're just iterating and taking like, okay, this is less than 2, it goes into this group. This is greater than 2, it goes into that group. That's what this loop is doing.
Could you expand the font size?
Oh, I can, sorry. Oh, that's too big.
It's okay.
Okay, so
we only have 2 minutes.
We only have 2 minutes. Oh boy. I will not be able to show you the code for this. Okay, and this last step is we are taking.
But 5 minutes expand is okay.
5 minutes expand is okay. I will expand for 5 minutes now. Okay, so what happened here? This is spec internal data structure. This cannot be exposed to JavaScript developers. The reason it's written like this is to make it as clear as possible the intention to implementers. Here, step 7, we are creating our first JavaScript object. This is an ordinary JavaScript object like the one that you use as a JavaScript developer. And on step 8, we remove from the spec internal data structure, and we copy everything over to the JavaScript level object. And it's easier to see on that side because things aren't in the way there. Okay, so this is the whole of the algorithm that implements group by. You can probably imagine how you would implement it in JavaScript. And since we're expanding for 5 minutes, I'm just going to go ahead and very quickly do that. Okay, so here we are. Is this big enough? It's big enough for the front. Is it big enough for the back? Probably not. Okay, come find me after, and we will walk through this together. This is going to be the very fast version. Let's go. Variable O equals, and then toObject this. That was obvious, wasn't it? ToObject is actually implemented in C++. We have some hooks that allow us to directly access C++ code from the self-hosted code. It's a little bit magic. We won't get into it, but it looks exactly like what we discussed in the spec. Next, toLength. That's probably also obvious. Variable length equals toLength. Step 3, we mentioned that it is an if statement, and it looks exactly like that when you implement it. It's an if statement, and we're going to throw a type error. Step 5, let groups be a new empty list. Well, why don't we do this? Actually, that's a terrible idea, because this is an unforgeable access to an array, which means that this array is accessible by users to override. So if a user goes and adds some new prototype methods on their array, on their access to the array, we're actually going to have it in the JavaScript engine. That's bad, because then this algorithm might not work as intended because the user hasn't modified how the engine works. So we never do that. Here, let me move that down. Instead of doing that, we have a way to create a safe array. It's called newList. So if you're ever working inside of the JavaScript engine and trying to implement your own proposal, you might get a review comment like that saying like, no, you can't use a bare array like that. Moving on, we are extracting this argument. There's also some implementation-specific information here. We don't need to dive into that, but it's also implementation-related. Stop that. Okay, moving on. Here's our loop. It's a for loop. Actually, it's just a for loop. And we skip the let pk2string line, because k is coerced into a string because we are in JavaScript. As soon as we do a property access within JavaScript, we actually cover that step. That's why we don't have to do it. So we extract the value, the k value, and then we call the content function. So call content function, this line here. This is calling your user code when you do array group by, and that function that you pass to group by, this is where it's being called. And then this section of the steps, this is where we are actually adding the values directly onto that array, onto that list, that internal data structure. Then we create our standard JavaScript object. Then we take everything out of our list and attach it to the JavaScript object. And then we return our object. That's it, that's the implementation, and we're done. I'm going to build it very quickly. There we go, it's being built. I have 2 minutes of my extended period. Come find me later if you want to see this working. So, do you want to do this yourself? Maybe. There's a tutorial that is on GitHub that you can find. It's a tutorial based on a class that I taught at the University of Bergen. It's been written by one of the students, Rolf Blumsrud, and it takes you through the entire process of writing the array grouping feature by yourself, as well as explaining this in much greater detail. You will also learn about testing and other aspects of writing the array grouping proposal. Please find me later or look at the slides. It's linked from the slides if you want to find it. So, we've done the implementation, but the important thing about stage 3 is that stage 3 implementations reveal defects in the proposal. Defects we couldn't anticipate. In particular, the defect that we ran into was web compatibility issue with the Sugar.js library. It took some investigation, but we found that the array prototype was being modified. This is a common reason for web compatibility issues. We tracked all of the websites that were using the Sugar.js library, and we counted them up and found that there were only 1,000. As a result, our first step for addressing the web compatibility issue was to go ahead and do outreach first and ask the library authors, the people who integrated the older versions of Sugar.js to update the Sugar.js version so that we wouldn't have the web compatibility issue. We managed to reach a couple of them, but most of them did not respond. As a result, our attempt at outreach failed. That meant that we had to choose a different path for implementing this feature. The decision was to change the name from group by to group. The argument here was that group is probably used on arrays as a way to create data. So to say that it's group 1, 2, or 3. So it should be more web compatible than group by. We were very mistaken. It was not more web compatible than group by, it was less. And unfortunately, it took even more time to discover the web compatibility breakage because it was so hard to detect. This was again reported on Firefox nightly. Recall that we had the expectation that because it's data property access, it wouldn't be a problem. However, there was code like this, and I think you can imagine why this code would be a problem if we have now added a prototype method called group for a code base which uses group as a data property that they're accessing. The result is this would have been falsy because group is always set. So code that was relying on this completely broke, but without any errors. And the result was sometimes like a widget wouldn't display, and other times the entire website would be broken. We had fewer options to address this, because unlike the previous breakage, it was undetectable. So we had only one choice, which was to redesign the feature. The redesign of the feature considered what are we actually doing here? We are changing an array into an object. So why don't we make it a static method where the array is passed into an object and the static method handles the conversion. It's very similar to object.fromValues, for example, as an API. So here's the alteration. We go from this to this. It's a significant redesign. How do we deal with a significant redesign at the committee level? We are in stage 3. When there is a huge redesign, we want to communicate to users. Many users consider stage 3 as the point that a feature is almost finished. Therefore, we demoted a stage in order to better communicate to users such as yourself that the feature requires a significant redesign and needs your feedback once more. This made space for developers to come and talk to us. Now, the feature advanced to stage 3 again just this summer, and it is going to be going for stage 4 with the new static methods on the object built-in. Actually, next week. Next week is the next TC39 meeting. So we are about to enter stage 4, and stage 4 means that the feature is finished. That's it. I could summarize this, but come find me after the talk. I've already taken up enough of your time. So let's jump to the acknowledgements, which I'd like to acknowledge my colleague Arai, who helped localize the slides, and Dan Miner, who helped with the content, as well as my collaborators from the University of Bergen and the proposal author, Justin Ridgewell. Thank you very much.